Okay, welcome to our channel and you are watching Chemicals. So today we are going to discuss point group. Actually, in molecular structures are infinitely varied. Nevertheless, you can categorize them due to depending upon the some symmetry operation and symmetry elements present on them. Okay, and to categorize them, you have to perform some symmetry operation, as I say, the symmetry operation. But in every symmetry operation, there will be a point, the center of gravity point for each molecule, that will be unchanged. That's why the group formed or the category formed by this symmetry operation, these are called point groups. Okay, as one point is all in every time unchanged. So here you can see a flow chart, and you can see it in every book actually, like GUI or like Michelin and Car, what I say, in any point of time point group. Okay, cotton. So I don't actually want to waste your time. That's why I already written down this. So what is this? There basically molecules are depending upon their number of symmetry elements present. Molecular classified into two groups, like groups with higher symmetry, groups with lower symmetry, and group with intermediate symmetry. Group or like group which possess CN. So actually, group with lower symmetry. There's in case of actually linear molecule, linear molecule actually possesses one C infinite axis. C infinite. What is C infinite axis? It is a proper axis of symmetry, but you can vary the angle which in every you want any angle. In any angle you can actually rotate it, and you will come with a C infinite axis. So there is no barrier in angle. So actually any linear molecule possesses C infinite axis. So in case of linear molecule, if C infinity is there, Y means yes. In this, Y means yes and N means no. Okay. So if any molecule possessing C infinity axis, then you have to go to I. What is I? You already know, that is center of inversion. So at first, if it has C infinity, then it has I. So those two things have, then the point group will be D infinity H. But it has a C infinity, but it doesn't have N I. So then the point group will be C infinity B. Don't worry, I will give a example for each of the cases. I am just going through the flow chart. Okay. Then if C infinity is not there, then you have to go for Cn. Any Cn. Okay. You have to go for Cn. If Cn is there, then one case appears. If Cn is not there, we are now talking about group with lower symmetry. So let us now assume your molecule doesn't have C infinity and doesn't have Cn also. So if Cn is not there, then you have to go to the plane, sigma, plane of symmetry. Cn is not there, but plane is there. That means your molecule is possessing only identity and sigma. Identity is everywhere. So if your molecule is possessing only sigma, your point group will be Cs. If even sigma is not also there, then you have to go for I. That is inversion. If inversion center is there, that means your molecule is only possessing an inversion. Your point group will be Ci. And again, if your molecule is not possessing any sigma or any I, then your molecule is only possessing C1. That means any molecule which doesn't have any symmetry other than identity, that these things will be in this point group C1. So in this three CS, Ci, C1, all these things are actually groups with lower symmetry. Now, groups which contain Cn axis. That means this case, when Cn is present. Now what I have to think about. When Cn is present, then I have to go for n number of C2 perpendicular to Cn. Does it there or not? I have to just check it. My molecule has a Cn, then I have to go this way. If this is not there, okay, if this is not there, then you have to find for S2n. You know Sn, what Sn is. That means let us think like your molecule has a one C2, but it doesn't have any other C2, other two C2 perpendicular to it. So what do you have to find for? S4. Is your molecule contain any S4? If yes, then your point group will be S4 or like S2N. But if no, then you have to go for sigma H. Okay, I already talked about what is sigma H is or like that. So if your molecule contains sigma H, then your point group will be CNH, and will be this part which I am talking. This is very important. If you go through any question paper like NET or GATE, they actually ask you what is the point group of this molecule, and basically generally most of the molecules belong to this phase. Okay, so now again I'm going. If my molecule is having a sigma H, then it will be CNH. But if not, then I have to go for sigma V, n number of sigma V. Suppose my molecule has C5, so and my molecule doesn't have any sigma H, so I have to go for, does my molecule have any sigma V, high sigma V? If yes, then my point will be CNV, CNH, CNV. You can easily remember sigma H is present, that's why CNH. Sigma V is present, that's CNV. And always sigma H gets overruns over sigma V. In every case, in this case also I show you here. Every case you have to first find for sigma H, then if sigma is not present there, then you have to go for sigma V. So CNH I got, then CNV. And if sigma H is not there, sigma NV is not there, then I have to go for CN. Okay. So that doesn't happen. So my point group will be CN. So I got 3. But if n number of C2 perpendicular to Cn is present in your molecule, then again you have to follow the same sequence. So is your molecule contain sigma H? So if sigma H is there, now in every case, when the perpendicular n number of perpendicular C2 is present, then point group name of point group will start with a D. So now, if your point group is containing one sigma H, then your point group name will be DNH. If not, then you have to find for just like that sigma V, n number sigma V. If it's present, it will be DNV. This thing you have to actually remember. But because CNV, but in this case, same thing for the same case, you have to take out DNV. You can find it like DNV is a very common word, do not disturb. You can remind it like this, DNV. Always D will go with D, but V will go with C. Okay. So if sigma V is not also present there, then your point will be DN. Okay. So this is the flowchart, and there are some molecules with higher symmetry, higher number of symmetry like 5C5, C3. So these are not actually, this doesn't require much discussion. This point group with high symmetry are like tetrahedral, icosahedral, and octahedral. There are 3 groups present. Here CH4, like you already know this structure is tetrahedral. Then it will be in the point group tetrahedral. And in case of boron compound, there are compounds that will be icosahedral, and octahedral is also good. So basically, questions was asked based upon this question. So you need to remember this, and you can get it. I already told you. You can get it in any book, any group theory book or any inorganic book. Okay. So now let me come to the most important part. That is examples. Okay. Actually, these things you can't remember without doing any examples. You have to practice a lot of examples. That's why it will be. You don't have to then remember also. You can easily tell what will be the point. So let me take one example. Go. So in this molecule, what does have this molecule have? What the point? Here no CN is present because these 3 are this all are different. Any I, no CN, no sigma also. So nothing is present except identity. What will be the point? There are C1. Okay. Now we will use in this case, this is a planar molecule. Okay. This is not. This is like a tetrahedral. but this is a planar molecule. So you need to remember one thing: any planar molecule will contain a plane, contain a sigma, which is here that molecular plane. Any planar, if you take any planar molecule, the molecular plane, the plane of the blackboard. In this case, also the plane of the blackboard is molecular plane. So this molecule doesn't contain any C or I, but it contains one sigma. So if you go through the flow chart, like where Cn is not present, then you have to go for sigma present. Then if yes, it will be Cs. We already know that. So the point will be Cs. Let me take one. Sorry. In this case, any Cn, there's so in this molecule, okay, what is their symmetry elements? This molecule doesn't have any plane or Cn. If you can get any Cn, these three are different. So there is no Cn, and this is a tetrahedral type molecule. This thing are tetrahedral. This is also, so there is no plane also. But if you observe it carefully, there is a I, because this Cn is back of the bone and this here is above the bone, like this. So if you draw a line this to this, and in this is true for H also, and this F also. So there is a I. So this molecule contains only I, or not other than this. Okay. So this will be Ci, as you know. Now come to this hydrogen peroxide. Actually, the point group of hydrogen peroxide depend upon how you write it. If you write hydrogen peroxide like this is just a planar, there will be one point group. If like this open group conformation, then the point group will be other. So what will be the point group of this hydrogen peroxide? This is not planar. You can easily show. This is one thing is there, other thing is actually back of the board. So here actually you can get a C2 axis, because this is above and this is below. So you just rotate it, it will get below and it will come above. So this is only C2, nothing is there, no sigma, no other thing. Okay, so the point group will be C2. PPH3. You can think of the PPH is planar, but PPH is not, because of 3 bulky pH group. This is not planar. Okay, so no plane is actually present there, and I is not there, because this thing there is back end there is also. So there is no I and no sigma. Only this thing has a C3, because this angle is 120. So if you rotate it 120, this pH will come here, this will come here, and this will come here. So this only a C3. The point group will be C3. Let me erase this thing. It looks very clumsy. Let us just find out point group for linear. Okay, this is a linear, so it contains a C infinity axis. Okay, so if you got a C infinity axis, then you have to find out for I. Does this molecule have any I? Yes, because if you draw a line, so here one I is present, because H is converting to one H, C is again C. So I is present. So sigma infinity and I, what does this give? D infinity H. If I is present, then will be D. But this is also a linear one, there is CL. There is C infinity is there. Is there any I? Because this is H, this is CL. There is no I is present. So this sigma infinity B. Okay, so you can check it with taking any of the linear molecule. I'm giving you a question like what will be the point group of HCN? Okay, what will be the point group of CO2, CO? You just take it out for yourself. Now, in this case, this is going to be pretty interesting. This is a planar molecule, okay? So, here is one cell and one cell is trans. So, what you have to do? You have to first go for any CN is present or not. Yes, one CN is present. You just take this. This is a planar and this is about to this CN. Like there is a CN. What is C2? If you rotate it at 90 and then one again 90, Cl will come here at first and Cl will actually replace this. Cl will come to this place and this H will also. So there is a one C2. Now we have to find for, is there any n number of C2, like 2 C2 is perpendicular to this molecule, any other 2 C2? There's no C2, because if you take a plan, if you think of a planar C2, this is not going to give you this same indistinguishable form, because if you rotate it, Cl will come here, but here is H, so it will not. Any other C2, like here, it is not also. Cl will come here if there is H is present. So no perpendicular, to no two perpendicular C2 to C2, this C2, okay. So actually this is a C2 but no perpendicular. But now what you have to think? Sigma H. Does this molecule contain any sigma H? As you know, any planar molecule have a sigma, which is its molecular plane. This, and what is sigma H? Any plane perpendicular to your principal axis, that is called sigma H. If any plane is perpendicular to your principal axis of symmetry, then it will be sigma H. But if it is not, it is containing your C2 or Cn, whatever. If the sigma containing your Cn axis, then that will be called sigma V. But if it is perpendicular to your Cn, then it will call sigma H. So this is your C2 and your sigma is like this. So sigma is perpendicular to this. So this molecule contains sigma H. So what is this present here? One C2 and one sigma H is also there. So that means that point group will be C2H. Okay, I think no problem there. Now let me come to this. I already shown you on my video that this molecule contains the C2, because this H is going to just transform to this C2. This H is going to transform to this. So this molecule contains a C2. Does this molecule contain any plane? Yes, because it's a planar molecule, so it is a plane. But now this plane is containing your C2, because C2 is also in this plane, and same plane, your sigma is also. The sigma is containing your C2. That means this sigma is your sigma V. And again, one sigma you can think of that is along my hand. This is also a sigma, but this is also again containing your this C2 axis. So this is also a sigma V. Does this have any sigma? There is no sigma. So there is no sigma H, but C2 and n number of sigma V, that means 2 sigma V is present. So what will be the point group? C2V. Okay. Now let me come to this thing. NH3. This is a tetrahedral type, like the hybridization. So this is actually, this doesn't have any sigma or I, but this have an axis. Like if you consider this through only this n, this is C3, because every H is apart from 120 degree. So this molecule contains a C3. Does this molecule contain any sigma? Yes, it does. Because if you take a sigma containing this N and this H, so it is going to divide the molecule into H and H. So there is a sigma, and in every NH, so there is 3 sigma containing 1 N and 1 H. So they say 3 sigma, and these are also containing this C3. Because if you think like that, NH, so it will go into your C3 also. So these sigmas are sigma V. There is one C3 and one sigma B. So what will be the point group? C3B. Now come to the last example I have written down. In this case, no plane is there. This molecule only contain a C3. Okay. Other than C3, there is nothing is there. You can check it. So, what will be the point group? C3. Let me just take two other examples. The PTCl4. PTCl4 is a quadruplet complex. Quadruplet complex, okay. So what is the structure of PTCl4? So PTCl4 is, if PTCl4 is in the black plane of the blackboard, and you have to find out, is there any C2, Cn? Yes, but that is perpendicular to this. Just run this. There is a C4. You can easily, because this Cl are 90 degrees to each other. So there is a C4. Now, does this molecule have containing any plane? Yes, the molecular plane itself, one molecular plane is there, and the molecular plane. Now, this is your C4, and molecular plane is plane of the blackboard. So these are perpendicular to each other. So there is a sigma h. And okay, sorry, I forgot to mention there. Is there any in number of C2? That means in this case, 4 C2 is there or not? 4 C2 that is perpendicular to Cn is there or not? Just think about this. If you take a C2 with containing this C2 is going to change your molecule Cl to Cl. So there is a C2. Again, there is also a C2. If this you take and this, there is a 4 C2. So this is also there. So that means if this requirement is fulfilled, so the point group name will be D with D. And now I already told that molecule containing one H. That means the point group will be DNH. So that means the point group will be D4H. Okay. Sorry for the last example actually. In case of COEN3, I told it this is C3. This is not C3 because one C. If you just draw. This molecule contains one C3 here and 3 C2. Okay, 3 C2 because this is above the plane and this is not. So this 3 C2 is also there perpendicular to. So the point group will be D3. Okay. Actually, there is several infinite number of examples you can go through. I don't want to actually discuss all the, and it is not possible for me also to discuss all of the examples. You just go through any of the books. I'll recommend you one book, Alan Vincent. There is a lot of problem there, a lot of point groups problems. See 20 examples. Like that you can go through this, or like any book, you just go through the point group. What will be the point group, and let me know if any problem arises for you. Okay, so that is what for today. Okay, thank you, and keep watching our channel. Subscribe and share among your friends, your siblings, whatever.